In today's video, I'm going to talk about the use of one-dimensional arrays and array lists together with for loops and for each loops, and then finish up with some of the different algorithms that are used in those scenarios. So let's go ahead and get started with just the basic characteristics of an array. So for starters, an array is an object, and the variable name is a reference variable for where the array is stored. Arrays can only contain one data type and have a fixed size. And this fixed size can be accessed with arr.length. The indices start at 0 and end at length -1. Now, when we create an array, because it is an object, it has to be initialized and set up and be ready to go. And the default values are filled in with 0 or 0.0 for integers or doubles, false for booleans, and null for strings or objects. So I'll just add that in there. If you were to have an array of a like a user created data type, and you instantiate it to be like of size 5, then each of those elements would have an initial value of null. Now, there are several ways that we can work with our array. So if we walk through these couple different lines of code here, this first one where it says ARR and then nothing is essentially right now equal to a null reference. That array has no size, nothing was set up, it is not ready to use. The only thing that it has done is made a variable name. Now, in the next line of code, where I say ARR equals new int of size 5, this has set up and instantiated a space for 5 integers, and then those default values of 0 have all been filled in. Now in this next line right here, where I say ARR2 equals ARR, what this is doing is this is making another address reference to refer to the same place. So notice that here I only have one array. I have one array with 2 names that can be used to refer to it. So if I said ARR or ARR2, they are both talking about the same green array there, and any changes made to one will be noticeable by the other. And then this last syntax here, this is called an initializer list, and this allows us to set up an array reference and then also fill the array at the same time. And in this case, it knows how big to make the array because of the number of elements in the array. Now, when we are working with these arrays, it is very, very common to loop through them. And we can use either a regular for loop, which we see here, or a for each loop, which we see here. Now, in terms of the differences between them, the regular for loop can do everything that a for each loop can do, but it also has some more flexibility here. So here you want to define your start and end, and then your update. Okay, so if we look at here, this is saying I'm going to start at 0. I'm going to end as long as, or once I is no longer less than the array name.length, then I'm going to stop. And then I'm going to update by doing I++. Now on the flip side, this for each loop is doing the same thing. What a for each loop is going to do is it will traverse through every value from index 0 to the end. So if that's what I'm doing, if I'm going from the first index to the last, then a for each loop is a much quicker and simpler way to write the code. However, let's say I wanted to start at index 1, or I needed to compare consecutive indices, or I needed to stop I don't know, 2 before the end, then in those cases I could not use a for each loop. Another thing that's important to recognize is that within this for each loop right here, I am making a temporary variable. So each time through, I am making this temporary variable. I am copying the value in. So like right here, my first value for the in the array was 1. So it's copying in the value 1 in for A, and then after it does what it's supposed to do, that is gone. And then next time through, now A equals 4. Does what it's going to do, and then that's done. A is 8. Does what it's going to do, and now that's gone. And that's important to recognize because we can't make permanent changes to these primitive values like I could if I was working with a regular array and not the for each notation. Now, on the contrary, we have an array list. An array list is also an object. The variable name is a reference variable, so just like with an array. And one thing that is different here is that we can only contain objects, and it does not have a fixed size. We find the size of the array list by saying arr.size parentheses. Just like with an array, the indices go from 0 to size minus 1. And when we first create our array list, it starts out empty. We can add elements by using the add method. So you can see here in this scenario, I have created this array list called names. And once I create it, it is currently ready to go. There's nothing in it. And then I go ahead and I add Mike. And so now names has the value of Mike. And then I use this set method. And set is essentially a replace. So I'm replacing the value at index 0, and I'm replacing it with Joe. And so right now this array list just has one value, and that one value is Joe. Now there are a lot of methods that we can use with our array lists. This first part up here where I'm showing you how to instantiate, it's important to note that this is no longer needed, but we do want this. If you don't include the first one on the left before the equals, then the array list will not have its object type saved. And every time you want to work with the array list elements, you have to typecast it, which is a super huge pain. The one on the right that is over here, this is no longer needed, but I figured I'd mention it because if you're looking at some older example problems, you will still see that used. So we have two different types of methods to add elements. The first one just simply adds it to the end, and then the second one inserts the element at the index specified. And after it inserts, everything moves down to the right. Now next we have this remove method, which does like it says. It removes the element at index I, and then everything shifts left. We have your basic getter, dot size to get the size of the array, and then dot set, which we already talked about, and set essentially replaces. Now, one thing that I do want to mention is that both remove and set, these two methods return the old value that is no longer there. So when you remove an element, remove returns the value that you removed. And when you say dot set is going to go ahead and replace something, and it will return the value that you have in fact replaced. All right, so here I have an array list of names with the names Jillian, Marcus, Willow, and Zach. And here I have a regular for loop. And you'll notice that I have to say with the index is less than names.size. And then to access each element, I can say names.getI. If all I want to do is access every element in my array list, then that for each loop is way easier to work with. So again, just a reminder, the for each loop is great when you're trying to access every element from the beginning to the end. And that's what I'm doing in this example. And I'm essentially saying for each string that I'm going to call S inside my array list names, print out S. And so that's how this abbreviated notation works for us. All right, now one of the things that's important to recognize is sometimes we can rewrite a regular for loop as a for each loop. Sometimes we can't. Well, in this case, I've got this method, and this method is checking to see if for each of these words in my array list, does it start with my beginning? And if it does, I want to increment my counter. So this is an example where I can absolutely use a for each loop. And so let me start by replacing my for loop header, which goes from 0 to the end. So I'm going to say for, I want to figure out my data type. Since I'm working with strings, I'm going to say for string S, and then I use a colon, and then I'm going to say the name of the array list, which is words. So for each string S inside words, I'm going to do the following. So if, and then here, I just replace words.getI with S. So I'm going to say if S dot to lowercase dot starts with beginning, pretend this is beginning, then I'm going to do num plus plus. So we can see that the logic is the same. It just made our syntax a little bit easier, which is super helpful when you are tracing code, or I'm sorry, not tracing code, when you are writing your own code for your FRQ problems. All right, on this next section, we are tracing code, and this is a really common style of problem you'll see to test if you understand how these for each loops work. So I mentioned this earlier, but when we're working with primitive data, and integers are primitive data, if I am going through and I am saying for each int n in my list, that is going to make a temporary variable. And so it'll take that value and copy it in here. And then it will add 10 to that value. And then when the loop is done, that whole temporary variable is gone. And so the end result is that here I would print out my original array, 1, 2, 3, 4. And then I would try to add 10, but fail because I'd only be adding 10 to my temporary copies. And then when I print it again, I would just be printing out 1, 2, 3, 4. So it's important to note that when we are working with primitive data, like ints, doubles, booleans, primitive data, the for each cannot change anything. All right, last but not least, common algorithms that we should know. So it's really common to ask you to write code to find the smallest or the largest value in an array, or to return the index of the first time or the last time when something occurred. These are great things for you to practice writing. A great resource to use to get some practice problems here is that Coding Bat website that we used in class. You'll see a lot of practice problems in the array section. And it's also important to recognize when you're trying to check if elements are in ascending or descending order. So in this case, in order to do that, you have to check consecutive elements. And when we're checking consecutive elements, you can either do that with I and I plus 1 or I minus 1 and I. Regardless of how you plan to go about doing that, you have to make sure that your for loop header accommodates for it so that you don't go out of bounds. We don't want that to happen, okay? So what do I mean by that? Let's say I was going to go with this notation here. So then that means that I have to be able to check index 0 with 1, and 1 with 2, and 2 with 3, all the way up until I'm at the second to last value so that I don't go out of bounds when I'm on the last one. So here, I would say for int I equals 0, I is less than arr.length minus 1, I plus plus, and then I can say if arri, I don't know, see if they're equal, equals arr I plus 1, then I'm going to do something, okay? So whatever it is that I want to do. So in this case, since I'm writing I plus 1, I want to look at my maximum value and just make sure that my maximum value won't go out of bounds when I am on that last one. And the same thing is true if I were doing this bottom scenario here. In this case, I have to look at my first value because I'm doing I minus 1. So in that case, I would want to say for int I equals 1, I is less than arr.length I plus plus, and then here I would say if arr I minus 1 equals arr I. So in this case, because I'm doing I minus 1, I need to make sure that my starting value is smaller. All right, well, I hope this was helpful for a review on arrays, and yeah, good luck.